Math Analyzers. We are finally ready to start talking about the unit circle. So here we are. We're going to take our pieces from chapter 8 together with the two things we've been talking about as far as angles go in chapter 9, and we're going to put those into a circle that have a radius of 1. That's why it's called the unit circle, because it has a radius of 1. Its equation, the equation of this circle is x squared plus y squared equals 1. Okay, and that's because this radius, this distance from here to here is 1. All right, now all that stuff we do with trig from this point forward will all kind of stem from working right here and understanding what each of the points around the unit circle's measures really mean. Okay, and so we're just going to start by talking about the unit circle as a whole. Okay, so those relationships in those right triangles, those special right triangles that we've been looking at, the 30, 60, 90, and the 45, 45, 90 right triangles, the things that we've been doing with those as far as looking at the sides in proportion to their angles is actually what's going to help us fill in points around the unit circle. So this actually kind of comes together really nicely with our work from chapter 8 and then our work here in chapter 9. Okay, we're going to use this idea of angles in the coordinate plane along with the special right triangles to help us think about places around the outside of this circle. Okay, the cool thing about a unit circle is we know 4 points for sure, and they're integer points. And those 4 points around it, right? We know the center is 0, 0. Okay, those 4 points around it, and we'll start in quadrant 1, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So these points all surround the circle, right? And that's what we would, if we were to graph this, we would plot 0, 0, and then count out 1 each direction around the radius and connect. And that's how we would create that circle if we were tasked to graph it, right? So a lot is going to come together. Don't get overwhelmed. We're going to spend 2 days filling out unit circles, just filling out unit circles. We're going to go back and forth between radians and degrees. We're going to look at the specific points around the unit circle at 30 degrees, 45 degrees, and 60 degrees. And then, of course, we've got our 90 degrees that we're going to kind of analyze. And we're going to use all this stuff to help us after this lesson. And so let's just put it all together in a unit circle, right? Okay, so this is the first thing I want you to really just look at is this is a fully filled in unit circle, okay? I'm not going to talk about the trig stuff about it yet. I'm going to wait until after the quiz to do that. But there are some trigonometric relationships that result from the points around the unit circle. Now, we'll start here with the very first point, that 1, 0. Okay, this is where your 0 degrees on your circle. So that's kind of your starting point. We'll start there and we'll go into quadrant 1, and we'll just kind of look at quadrant 1 for right now. Okay, and as we go around, here is where a 30-degree reference angle comes up. As we know, we can convert that into radians, and that's pi over 6 radians. This point on the circle is known as radical 3 over 2, comma 1/2. I'll discuss that. For now, just know that that's the point. Next, continue going up, right? We go up to the 45-degree angle right here. This 45-degree angle is also known as pi over 4 in radian measure. This point that it forms on the outside of the circle is radical 2 over 2, radical 2 over 2. This probably sounds familiar, doesn't it? Continuing, now we go to the 60-degree angle right here. And when we get to the 60 degrees, we know that 60 degrees converts into pi over 3 radians. And this point on the outside of the unit circle here, where the 60-degree angle meets, is 1/2 comma radical 3/2. Then we get up to the 90-degree angle, which converts into radians as pi/2. And that point is 0, 1. Now just look at the first quadrant. Look at the 60-degree versus the 30-degree points. And what do you notice? The x and y coordinates are opposites of each other. What do you notice about the 45-degree angle point? It's radical 2/2, comma radical 2/2. It's the same coordinates in x and y. Now take this away and look at the rest of the circle. It's all versions of quadrant 1. All those points all around it are versions of what's happening in quadrant 1, where everything is positive. And so the next phase you want to put together and remember, and this is from when you first even saw the coordinate plane, is that over here in quadrant 2, x values are negative. So notice on this side of the circle, which makes perfect sense because circles are symmetric, right, or all the way around, is these are the same points, just different x values. When you get into quadrant 3, right, negative x values. When you get into quadrant 3, both are negative. So in the points, both the x and the y coordinates are negative, but still the same points that we saw before. And then when you get into quadrant 4, x's are positive again, but the y's stay negative. So if you know how to do the first quadrant in a unit circle, you can do all the rest of the unit circle just fine. We can always use our ability to convert between radians and degrees using pi/180 or 180/pi. So that we can always figure out just fine. And then these are based on our special right triangles and the side relationships around the special right triangles. That's where we get those points from. That's why it was so important that we knew that. And you'll notice that when it came to the 45, 45, 90 right triangle, which of course, if I drew a line right here and created a right triangle out of this, we know that it's 1, 1, radical 2, right? So then we'd have to rationalize it when we're making that point because that's our x value and our y value. So it all comes together, okay? It's all being put together. Most teachers would advise memorizing the unit circle. When I'm talking about it, I kind of advise just kind of know quadrant 1, and then you'll be able to figure everything else out. And as I fill in a blank unit circle with you today in the notes, you'll see how I do that. Okay, so I'll talk through all the things that I'm doing because I know quadrant 1, I can fill in the rest based on that knowledge. Okay, so let's look at what a classic blank unit circle to be filled in looks like. All right, this is what it looks like, where I give you a circle blown up, I give you spots for the degrees and spots for the radian measure for each of these lines. That's each of a radius that's built into the circle somewhere around it, right? And then I also have points on the end, coordinate points on the end for us to fill in the values of each of those points. Now, when I do this, much like anything else that I do, I go for the low-hanging fruit. I do the easy stuff first. So first thing I want to do is fill in this first point that starts here at 0 degrees, right? So this is 0 degrees and 0 radians because nothing has happened yet at this point right here. And we're out 1 on the x-axis, so 1, 0 is our coordinate out there. Now, the first of our special degrees that we run into is 30 degrees. So let me start by filling in my degrees, okay? Then the next of my special degrees I will run into is 45 degrees. We're just going numerically. Then I run into 60 degrees. And then that gets me up to a right angle, 90 degrees up here. Okay. So just start with that particular thing. Now, up at 90 degrees, of course, we know what this point is, this coordinate out here. Now we're 0 on the x-axis, but we're up to positive 1 on the y, because we know that this radius, this length is 1 right here. So now let's talk about those matching radian measures for each of these angles, okay? So 45 degrees is easy because it's pi over 4. And what do we start with for all the 45s? The 4, right? So all the 45-degree angles will be something pi over 4. 90 degrees is pi over 2, 1/2 of pi, right? Because we know that 180 is pi radians. So 90 is pi over 2 radians. 90 degrees is pi over 2 radians. Those are the matchups. Now, here's how I remember the 60 and the 30, okay? These both have pi on the top, of course. Their denominators are opposite. So this is pi over 6, and this is pi over 3. Okay? That's how I remember those particular things. Now, let's think back to our 30, 60, 90 right triangles, okay? In a 30, 60, 90 right triangle, the sides are in proportion to the angles in 1, radical 3, 2. So since the hypotenuse is 2 for both of these, you're over 2 in all of the points, okay? Because the way you think of it is you go to this coordinate and you drop an altitude, and now you've got a 30, 60, 90 right triangle. So at this stage right here, both of these are over 2 in their coordinates because the hypotenuse is the 2 in the proportion of the sides. Okay, that's the first part, right? We know for 30 degrees, so this is my 30 degrees, across here is the 1, right? Well, this is how far up the y we got. So 1/2 is the y. Look, this is total of 1. Halfway up is our y coordinate here. That leaves the other one to be the radical 3. And now that I know that, if I go to the 60 degrees right here, where now we're in our angle in question is 60 degrees, you just invert these guys, flip it over. It's 1/2 is the x value, radical 3 over 2 is the y value of that coordinate. Okay. Now, the 45 is the easy one because in 45, 45, 90 right triangles, it's always 1, 1, radical 2. So you have to rationalize it because your hypotenuse is radical 2, right? Our hypotenuse here was 2, so we didn't have to worry about rationalizing these fractions. They come naturally rationalized. But when it comes to rationalizing the hypotenuse as 2 in your denominator, you multiply top and bottom by radical 2, so you get radical 2 over 2 as the fraction here. And because it's both sides, that also happens to be both coordinates are at radical 2 over 2. Now, like I said, if you memorize quadrant 1, if you just kind of know quadrant 1, or like I just did, figure quadrant 1, everyone else comes naturally. Okay, so now I can go back and I can fill in quadrant 2, quadrant 3, and quadrant 4 using what I already know is happening in quadrant 1. Okay, so let's head over to quadrant 2 and let's go to where the 30-degree reference angle is in quadrant 2. And that, think of it going this way, right? This is the reference angle. That's this guy. This is the 30-degree reference angle. So what's 180 minus 30? Well, this is 150 degrees right here. And 150 degrees in radians is 5 pi over 6. And the reason I know that is because, see, the 30-degree reference angles will be something pi over 6. Look how close I am to being at 1 full pi, right? So my closest numerator without being 6 pi over 6 is 5 pi over 6. And easily I can figure this in my graphing calculator. Let me just show you real quick how I do this. 150 divided by 180 comes out to be this, which if you put it in fraction form is 5 over 6. Okay, so we know that that 30-degree reference angle has to have a denominator of 6. Now go to the 45-degree reference angle. Oh, I'm so sorry. I got to do my coordinate first. My coordinate is the same as this coordinate, except now the x is negative. So radical 3 over 2 is just negative. 1/2 stays positive because we're in the positive y's still up here, right? This is positive y's, negative x's, positive y's. Now I can go to the 45-degree reference angle. And up here with the 45-degree reference angle, all you need to do is take 180 and, oops, how about 180 and subtract 45 from it to know what degree measure this is right here. And that would be 135 degrees, right? Now, remember, the 45-degree angles will all have a 4 in the denominator because 45, right, will have the 4 in the denominator. So I know it's something pi over 4. Well, I'm so close to having a full pi. What's one thing away from having a full 4 pi over 4? 3 pi over 4. And again, you can test this by taking 135 and dividing it by 180, turning that into radians, right? And then turn that into the fraction, and that's how you can test to make sure you're right with that. Now, again, the coordinate will be the same, just the x value is negative. So negative radical 2 over 2, radical 2 over 2, because the y's stay positive here. And the last reference angle over here is your 60-degree reference angle, right? So 180 minus 60 gives you that 120-degree reference angle. 60-degree reference angles have 3 as their denominator. So this will be 2 pi over 3. Because see, we're so close to having 3 pi over 3. We're just 1 away from it, right? Think of it as the thirds. The 60s are the thirds. Okay, we're so close to it. So 1 away is 2 pi over 3. And again, easily checked in your graphing calculator by taking 120 and dividing it by 180 to get this. And of course, you probably already know what that is in fraction form, but use your graphing calculator to switch it into fraction form, and that's what you get. Now the point, again, exactly the same as the 60-degree over here, but your x coordinate is negative, so negative 1/2, positive radical 3 over 2. This, of course, at the straight line is 180 degrees, which is pi radians. So we've gotten to approximately 3.14 radians around, right? Or radii covering the outside of our circle. That's where we got to. And of course, this coordinate is easy to know. We're in the negatives for x and 0 on the y. Now, I'm going to use the same technique in quadrant 3, where I look for the reference angles. So start with the 30-degree reference angle. So 180 plus 30, 210. And now we're over 1 because this is 1 pi, 1 full pi, right? So now all our fractions will be values over 1, getting us to 2 when we get all the way around for our radians. Okay, so we know that this, because it's a 30-degree reference angle, has to have a 6 in its denominator. Okay, so something 6 pi. Well, 5 pi over 6 was what we had right here at 150. Then this is 6 pi over 6. So this must be 7 pi over 6. This coordinate now has both negative. So negative radical 3 over 2, negative 1/2. The next reference angle is 45, right? So 180 plus 45, we're looking at 225. Really just think about adding 15 to that guy. And then you get here, and then you add 15 again to get here. Think of it that way. Now, these ones that are the 45-degree reference angle, they always have a denominator of 4. We had 3 pi over 4 here, so we were 3/4 of the way. Then this one's 4 pi over 4, so this is 5 pi over 4. Just one more than what we already had, right, as a whole, as one whole. Now, of course, we're in quadrant 3, so everyone's negative down here. So negative radical 2 over 2, negative radical 2 over 2. 60-degree reference angle, 180 plus 60, we end up at 240. This is a 60-degree reference angle, so 3 is the denominator. Okay, so something pi over 3, well, 2 pi over 3, 3 pi over 3, 4 pi over 3. Right? Going in thirds, so we've got to go just over 1. And then again, these are inverted from this coordinate right here. So the negative 1/2 comes first, and then the negative radical 3 over 2 for your y. That gets us down here to the point 0, -1 on our y-axis. And this is 270 degrees. So you add another 90 here, you get 270. And in radians, so this was pi over 2. This guy's 3 pi over 2. We're 1.5 times, right? 1.5 times that pi. Because you had 1 full pi here. Now you have 1 and then another half for radians. So keep going with your reference angles 30, 45, 60. So the 30-degree reference angle right here, okay? So this, we know now is the 360, right? We know this is the total 360, and that's 2 pi radians when we get to right here. So 360 minus 30 for our 30-degree reference angle is 330. Again, we know that those are always over 6. And so something pi over 6, well, when we get back up here, we have a total of 2 pi, so that's 12 pi over 6, right? So this, one less than that, must be 11 pi over 6. Now, again, that reference angle, that reference point is the same because it's still a 30-degree reference angle. So now it's a positive radical 3 over 2, but a negative 1/2 because we're still negatives in the y. 45-degree reference angle right here. So 360 minus 45, right, is the 315. You can think of it as just subtracting 15 from this guy. These always have a radian measure over 4. So something pi over 4. Well, if I got here to 2 pi, that would be 8 pi over 4, right? So subtract 1 from that. We're 1 down from having 2 pi total. That's 7 pi over 4. And we're still radical 2 over 2 for both coordinates, but now the x is positive, the y is negative. And then last one, 60-degree reference angle right here. So you can think of it as just adding 30 right from this one going over. Or you can think of it as 360 minus 60 as that. So it's 300 degrees in your circle. These 60-degree reference angles always have a denominator over 3, so it's something pi over 3. If I get all the way to 2 pi, that's 6 pi over 3. So 1 less than that is 5 pi over 3. And then if I'm thinking about coordinates, it's the opposite of what I have here. So a positive 1/2 is your x value, a negative radical 3 over 2. as your y value. That is how we fill in the unit circle when we're given a blank unit circle. I just want to reiterate one last point about the unit circle before I show you another unit circle being filled in, because we're going to stop here today. One last point about the unit circle is its equation, and I know I said this on the front page, but the equation of the unit circle, because your center is 0, 0, and your radius is 1, your equation of your unit circle is x squared plus y squared equals 1. So just a reiteration of the point that I made on the front. Okay. Pause here and kind of take it all in. I've converted a YouTube video of someone else filling this in as well, that they show you their tricks, and theirs might resonate better with you than mine did. Okay, so I just want to give you another perspective of someone else saying, you really don't have to memorize this, but if you know quadrant 1, everything else comes very easily. Okay, it all stems back from our work with our special right triangles. That's where these values come from. And in the next lesson, where I talk about the unit circle and these points on the outside again, I'm actually going to prove that to you with all the special right triangles. Okay, so for now, practice tonight filling in the blank unit circles I gave you on the homework. Use this to help you. I don't care. That's what it's there for. Let me know how it goes and ask me for help if you need it. Enjoy the other person giving you some unit circle perspective. But we're going to do this again. Okay, so just for now, fill in your blank unit circles and start practicing. All right, guys. I'll see you in a bit. Have fun.
Okay, this video shows you how to fill out the unit circle relatively easy. First thing you want to start out with is 0 degrees and 0 radians. Then we go up to here, we have how many degrees? 30, 45, and 60. Alright, then you know that pi over 6 is 30 degrees, pi over 4 is 45, and pi over 3 is 60. So that was easy. Up here on the top we have 90 degrees, pi over 2. Now let's go through the points. These ones are easy again. Unit circle, so the x value is 1, the y value is 0. Unit circle, the x value is 0, the y value is 1. Now how do you remember these 3 points? Either commit them to memory, or here's a little trick. They're all fractions, right? And they're all over 2. So we can basically write this. We can write divide by 2, 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 divide by 2. Alright, and then what we're going to do is start up here and walk straight down and go with 1, 2, 3, and then come back up the right side. 1, 2, 3. We are going to square root each of the numerators. So the square root of 1 is 1, the square root of 3, the square root of 2, the square root of 2, the square root of 3, and the square root of 1 is 1. So there we have it. We have all the points, all 3 points here, but they're just rotated, around here, this entire circle, the same 3 points. Sometimes they're negative, and sometimes they're positive, just depending on what quadrant they're in. We have basically all the degrees going around, and we have all the radians going around now as well. The radians are easy. Watch. Pi over 6, that's 30 degrees. Go another 30 degrees. 2 pi over 6. Another 30. 3 pi over 6. Another 30. 4 pi over 6. Another 30. 5 pi over 6. So I'm just going with that one. 5 pi over 6. Every odd I'm going to put down there. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. Again, only the odd ones. 11 pi over 6. All right, then we can go around and do the pi's over 3. 1 pi over 3. 2 pi over 3. 3 pi over 3. 4 pi over 3. See, I'm going 60 degrees every time I do it, and it's nice. It's there, so you can see the 60, right? Now I'm going to go another 60. That would be this length here. It's the same as this length here. 4 pi over 3, 5 pi over 3. Then 6 pi over 3. All right, let's go around and finish it off with the 45s. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Okay, then I got the easy ones. This is 360 degrees with 2 pi, right? This one over here is just pi, 180 degrees. This one's 270 degrees, 3 pi over 2. If you can't remember that 3 pi over 2, do the same kind of idea. 1 pi over 2, 2 pi over 2, right? They cancel out. And then 3 pi over 2, 4 pi over 2. Now you can go in and just fill in the degrees walking right around the circle. So that they're quite a bit easier, right? 120, 60. So then we have 135. It's a 45 degree angle. A 30 degree angle back from there is 150. 30 degrees after that's 210, 225, 240. Okay, keep going. 300, 30 degrees, right? 40 degrees, 315, it's like 45 degrees. And the last one, 330. And now we got to just go through there and put the points in. Now it's really easy. Remember, this point and this point have the same y value, right? So they have the same y value. They have the same x value, except it's negative. So I just go through here and I go minus 1/2. And I go root 3 over 2. Just all the x values are negative. Minus root 2 over 2. Root 2 over 2. Minus root 3 over 2. 1/2. X value, -1, y value, 0. Continue on. They're both negative. Minus 1/2 minus root 3 over 2. They're both negative. Minus root 2 over 2. Minus root 2 over 2. Minus root 3 over 2. Minus 1/2. Okay. Continuing on, 0, minus 1, and our last fourth quadrant, all the x values are positive, so positive 1/2, positive root 2 over 2, positive root 3 over 2. Now all my y values are negative. Negative 1/2, negative root 2 over 2, and negative root 3 over 2. Remember, all I did is take these 3 points and look at their x and y's where they're located. This is the same x value right down there, right? 1/2 to the right. And then the y value is just minus 3 over 2 versus the root 3 over 2. And that's how you can simply remember or create the unit circle at any time.